Hi everybody, welcome. Thanks for joining today. My name is Joe Travellini. I'm a product manager on Amazon Elastic File System, or EFS. And here today we're going to go over what's new with Amazon EFS. So here's what I plan on covering in today's session. First, we're going to level set. We're going to go over what EFS is, what it's designed for, some of its use cases, and customer adoption patterns. We'll then go over some of the service enhancements in the past year or so, and follow that with a review of our enterprise capabilities and our integrations with other AWS services, including some of the modern compute services. And we'll wrap things up talking about some of the recent EFS performance enhancements. So let's jump in. So in terms of level setting, right, what is Amazon EFS? We launched EFS back in 2016 to give customers a super simple, set and forget, fully managed cloud-native file system. It's really easy to get up and running in just seconds in as little as 2 clicks. And when you do that, you have petabyte scale elastic storage that's super easy to use. With EFS, we provide the capabilities and the integrations that you need to confidently run business-critical apps requiring shared file storage in the cloud. So let's talk about some of the characteristics of EFS. First, it's elastic, meaning we automatically scale up and down as you add and remove files from your file system, and you pay only for what you use. And your performance is going to automatically scale with your capacity. And again, that capacity can go up to petabytes in size. EFS is highly available and is designed to be highly durable. So today we offer a 4.9 service level agreement for availability, or SLA. And we're designed for 11 nines of data durability. So to achieve these levels of availability and durability, every file system entry, files, folders, links, they're redundantly stored within and across multiple availability zones, or AZs. So an EFS file system can withstand the total loss of a single AZ while providing the same quality of service in the other AZs. EFS is also serverless, meaning you don't need to provision or manage any infrastructure or capacity. So when your workload scales up, so does your file system, automatically accommodating any additional connection capacity that you might need. And speaking of connections, we support in EFS up to tens of thousands of concurrent client connections, no matter what type they are. So that could be like a traditional EC2 instance. Those could be containers, either in a self-managed container cluster or one of the AWS container services, like Amazon ECS, EKS, and Fargate, or serverless functions in AWS Lambda. And you can also access your file system from on-premises using AWS Direct Connect or AWS VPN. And then in terms of performance, EFS file systems provide low, consistent latencies in the single-digit millisecond range for active file system workloads, and can scale to tens of gigabytes a second of throughput and over 500,000 IOPS. And I'll talk more about performance towards the end of today's session. And finally, EFS's storage classes provide you with automatic cost optimization, so you can achieve an optimal price-performance blend for your workload. So we have a native lifecycle management capability that works with our storage classes. And what it does is it moves files between them. So any files that you aren't accessing frequently will get automatically moved from the standard storage class into the infrequent access, or IA, storage class. And that's completely transparent to you and to your application. No changes required. EFS IA costs 2.5 cents per gigabyte per month, which is 92% less than EFS standard. So with that built-in capability, and what we see is that roughly 80% of data isn't accessed frequently. I'll talk about that more in just a minute. You're going to achieve an effective storage price of just 8 cents per gigabyte per month. So let's talk about use cases for a minute. EFS is meant to serve the vast majority of file-based workloads, and it covers a wide spectrum of performance needs. That performance need can range from anything like single-threaded, latency-sensitive, things like developer productivity tools, to highly parallelized scale-out jobs requiring high throughput, things like big data analytics and machine learning, and everything in between. So when we talk to customers that are moving to and growing in the cloud with EFS, one thing that excites them, other than how easy it is to get started, is that EFS is helping minimize their technology risk along that cloud migration journey. So EFS is there every step of the way, right? From beginning to end. You're going to lift and shift your application with minimal disruption, with no changes required. And then maybe you're modernizing different components or microservices in the application, but EFS gives you that common thread throughout. So it really makes it easy for you to modernize your application stack, your technology stack on your own schedule. So again, in terms of lift and shift, not only can you move into something like EFS, where if you're backed by network file storage today, it's a consistent, familiar interface to your applications, your developers, and to your end users. But you're not, because it's fully managed, you don't have to get bogged down managing infrastructure. You're going to simplify your operations, you're going to reduce your cost, increase your agility, and get more out of your data simply by using a fully managed service. And once you've migrated your workload, we make it really easy for you to optimize your storage spend. So I talked about lifecycle management already. It's automatic cost savings. I'm going to talk about it in more depth in just a second. And with the rich set of services that AWS offers across different product categories, right, from compute to databases to analytics, storage, containers, and all the integrations that we built between them, that helps you easily modernize on your own schedule, but still gain immediate benefits just by being in the cloud on a fully managed service. And once you are modernized, you're running on fully managed elastic cloud infrastructure. That's going to result in further efficiency, both from a development perspective and an operational perspective, and it enables you to deliver more features and capabilities to your customers in a shorter amount of time. So here's an example of a customer testimonial, right? So Ancestry.com, you might be familiar with. They're a leading provider of family history services and really consumer genomics, if you think about it that way. They're harnessing data from different data sources. It might be public records, lineage and family trees, but also DNA. And they're helping their customers gain a deeper understanding about their background and their lives. What they wanted to do here is they wanted to move their entire genomic analytics pipeline processing from on-premises into the cloud. They wanted to leverage on-demand compute capacity and let their scientists increase the pace of innovation and experimentation to develop, more sophisticated, more precise and accurate analyses. Their workload, as you might expect, is relatively spiky. It's unpredictable. It makes it difficult to plan for, especially in a traditional on-premises environment. So in the cloud, they wanted to scale up their compute power just in time, on demand, right? Just when it was needed. They wanted to run their jobs, and as soon as they were done, they wanted to scale it all down. They wanted to tear it down to make sure they're effectively using their cloud spend, maybe saving on some cost. That variable demand in a traditional environment, it's really difficult to maintain, and it was getting in the way of their business productivity. So what they did is they chose to migrate from their on-premises storage solution into a fully managed AWS file storage service in EFS. They had two key migration requirements, if you will. Right? One of them was the project timeline. So they were given 6 months beginning to end to complete the project. And the second requirement was, they're trying to boost their data scientist productivity in the long term, but they weren't really willing to sacrifice any short-term interruptions to their scientists' workflow. So one of their other requirements was this needs to be really minimally disruptive to their scientist team, and they need to keep them productive while this migration was occurring. In terms of results, they ended up completing it in just 5 months' time. So they were 1 month ahead of schedule, and that's really all up, right? So that's from planning to execution to cutover and being in production in the cloud on EFS in just 5 months, and they had no disruption to their scientist team. So they ended up boosting their team's agility and productivity, and also reducing cost in the process. Let's now review what's new with EFS in the past year or so. While it's not explicitly called out on this screen here, I did want to mention that EFS is now available in every public AWS region. So in the last year alone, we launched EFS in 9 new regions, including 2 brand new AWS regions in Cape Town and Milan. In terms of the enterprise features, we've raised the bar on our service level agreement, our SLA, for availability from 3 nines to 4 nines. We also launched a pair of complementary security features, which I'm going to talk more about in just a minute. IAM authorization for NFS clients and EFS access points. So with these capabilities, you can control which clients have access to your file system and what permissions they have to the different data in your file system. So as an example, you can restrict access to all but a handful of users being able to attach or to connect to your file system, or you can guarantee that maybe a particular client or a specific application, you don't want them writing data, but you do want to give them a read-only view. You can perform that capability as well. So EFS access points and IAM have another example in just a minute. Really two cool new security and privacy features. And then finally, on lifecycle management, we extended deeper cost optimization that enables you to more quickly realize the benefits of tiering across the two EFS storage classes, EFS standard and EFS infrequent access. So integrations was another major theme for us this year. So we've made EFS available from all AWS compute models, right? So EC2 instances, but also our container services and our serverless functions. So that's Amazon ECS, Amazon EKS, and AWS Fargate. From a container perspective, you can now natively attach to an EFS file system, as well as AWS Lambda. And then going back to EC2 for a second, we integrated with the EC2 launch instance wizard. So if you use the AWS Management Console to spin up a new EC2 instance, you can now quickly and easily attach an EFS file system while launching those instances. Another area that we integrated with, really extended our integration, is in backup. So AWS Backup, if you're not familiar with that service, it gives you a way to centrally manage your backups across multiple AWS resources across different services. So when Backup launched in 2019, you could already create a backup plan inside the AWS Backup console or API to back up your EFS file system. This year, we made that even easier. It's now one-click simple natively inside the EFS console. So with what we call an automatic backup, in just the check of a checkbox, you can quickly create a nightly backup that's stored for 35 days inside AWS Backup. And you can customize that behavior if you like. Another enhancement to our backup integration that we launched this year is what we call item level recovery. So rather than needing to restore the entirety of your file system from backup, you can specify one or more paths. So, individual folders or directories or a collection of them, and restore just a subset of your data from backup. So that helps you maybe quickly realize a tighter recovery time objective, or RTO. And then in terms of performance, we've doubled our per client throughput from 250 megabytes per second to 500 megabytes per second. And we also launched a 5 times increase in our read IOPS in general purpose performance mode from 7,000 up to 35,000. So changing gears a little bit, I'm going to talk more about EFS pricing and cost optimization. And in terms of what's new, again, in the past year or so, we launched that deeper lifecycle management cost savings opportunity with a shorter lifecycle policy. So now just after 7 days, you can tier your files transparently and natively from EFS standard to EFS infrequent access. So one thing I want you to keep in mind here is really a key takeaway for EFS pricing from this session is that EFS costs just 8 cents per gigabyte per month. So again, lifecycle management is kind of the workhorse behind that. That's how you get data into that lower cost infrequent access storage class. And at that price of 8 cents, you're getting all the capabilities and fully managed features that EFS provides right out of the box. The high availability and data durability, the simplicity, the scalability to petabytes of data and tens of thousands of connections. All of that comes really right out of the box with EFS. And then if you're going to do a total cost of ownership, let's say you're trying to build and maintain your own file system storage infrastructure, and you need all those qualities, that multi-AZ availability and durability, the scalability. What you're going to find is, and we have deep dives in other reInvent talks this year and some examples out on our website that kind of show the line item breakdown of the TCO analysis. But what you'll find is that EFS is going to be 90% more cost effective than building it and doing it yourself. So breaking that down a little bit more, lifecycle management is enabled by default if you've created your file system inside the EFS console. You can turn it on at any time. Even if you created it using the API, you can go back in and enable lifecycle management. It's going to apply retroactively as well. What lifecycle management is doing is it's tracking the access time of every individual file. So it's monitoring your access pattern, and it's going to automatically save you money as your access patterns change, right? Your files are less frequently accessed. They'll move from EFS standard to EFS IA. And again, there's a generally accepted industry estimate that 80% of data isn't accessed very frequently. And what we did is we actually validated that estimate with our own usage data, right? So we've been in general availability in EFS for about 4.5 years now. And what we see in kind of empirical customer workloads is remarkably consistent with what industry analysts have estimated. So using that 80-20 rule again, where 20% of your files are actively used, the other 80% are not, your price in storing data in EFS is just 8 cents per gigabyte per month. So let me talk a little bit more about some of the characteristics of the two storage classes. EFS standard, it provides solid state drive performance for active file system workloads. Again, you'll get single-digit millisecond operation latencies on average at a price of 30 cents per gigabyte per month. But keep in mind all those qualities that I just talked about. The high availability, durability, scalability, all inclusive in that price point. And EFS IA costs 2.5 cents per gigabyte per month and gives you all of those same qualities with your first byte latencies in the double-digit millisecond range. So there's a slight price-performance trade-off associated with that. With EFS IA, you also have a data retrieval fee of 1 cent per gigabyte. So what we recommend customers plan for, if you don't have like a detailed breakdown on your access patterns, which files are frequently accessed versus not, we recommend planning for accessing the IA portion, that 80% portion of your data set, once in full per month. But again, looking at our usage data, it's actually a conservative estimate because what we see in practice is actually considerably lower than that. So just wrapping things up on storage classes, keep in mind that EFS file systems are going to transparently serve your data from both storage classes, standard and IA. All your files are readily accessible in that common file system namespace. So there are no changes required from your perspective in terms of your application or your usage pattern. They just look like files in a file system. Under the hood, we take care of that cost optimization for you and automatically save you money as your access patterns are changing. In terms of enterprise features and security, I mentioned earlier those two capabilities we launched at the beginning of the year in access points and IAM authorization. There's probably two fundamental goals that you're trying to realize in terms of identity and privacy for shared data sets. First, your storage and your data needs to be accessible only from clients that have a need to access it. And second, for specific pieces of data within the data set, you want the clients to provide authorizations, credentials with the permissions needed to modify, read, or write specific pieces of data. If you're trying to mount a file system, if an application is trying to access a file system that it shouldn't be, or it's trying to read or write data in a place that it doesn't belong, you want to prevent that or at least become aware of it. And these capabilities give you a really easy way to do just that. So with IAM, what you do is you attach a policy to your file system, and that policy governs its usage. So as an example, you can restrict access to a limited set of users, or you can enforce certain behaviors, like you can enforce that encryption is enabled, or you can provide that read-only view, or you can squash any attempt at using root access to the file system. With access points, you can synchronize users and groups and permissions across different clients, and you can prevent privilege escalation. So you do that by enforcing the identity of any connection using that access point. So that's particularly useful in serverless, like let's say in a Lambda function, where there's no first-class notion of a user, like a POSIX user identity, but also in containers, where a lot of the time the container identity is predetermined and baked into the image. And a lot of the time too, images will get built with root, which means your container might attempt to perform file system operations using root access. And chances are, especially in a production environment, that's not what you want your application to be doing. So here, we've given you a really simple mechanism with an access point and an IAM policy to provide an application-specific entry point into your data. So in conjunction with the IAM policies, where you can limit which users can use which access points, and again, with which permissions, you have that power and flexibility to create and manage a secure multi-tenant environment in a cloud-native way. So I mentioned earlier that broadening and deepening our integration with different AWS services, that's been a major theme for us. You can now use EFS to provide shared persistent storage across our modern compute services in containers and serverless. During reInvent this year, 2 of our customers, shown here, Acquia, they provide a hosted content management solution built on Drupal, as well as Assurion. They provide insurance, protection, and repair for consumer electronics devices. You might have seen that with maybe your smartphone or your tablet. They're both presenting on how they're using EFS. They're deploying their applications and their services in these modern compute environments, containers in the case of Acquia, serverless in the case of Assurion, backed by persistent EFS storage, and it's really helping them innovate their product offerings. So if you're interested in learning more about those, recommend you check out these sessions mentioned at the top right of the screen here, Storage 310 and Storage 312, for a deep dive, in the customer's own words, how are they reducing their overhead and focusing on building and innovating using EFS in conjunction with these modern services. Okay, and just highlighting again a little bit more about AWS Backup. You don't want to be in a situation where you've potentially lost an important piece of application data. Maybe a user accidentally deleted something. Especially when preventing that is so easy to avoid. So you can back up your file systems in just a single click in the the EFS console. And if you want to have a more sophisticated policy, maybe you want to back up every resource across any AWS service that's tagged with production. You can do that inside the AWS Backup console. You can also define rules with policies on when to migrate data from the warm backup tier to a colder backup tier to save on some cost. And again, in the event that you do need to restore some data, that item level recovery capability gives you a way to specify one or more paths, again, files or folders that you want to quickly restore from backup. And that's super useful maybe in a multi-tenant environment where you want to restore potentially a subset of your data for a particular customer of yours. So let's go over how EFS is evolving to meet our customers' ever-rising performance needs. So far this year, we've launched 3 different performance improvements. First, we've increased the read IOPS limit in general purpose performance mode by 5 times, from 7,000 IOPS to 35,000 IOPS. And this change has really benefited customers across the board, especially for things like developer productivity tools, ERP solutions, and document management. We also doubled our per client throughput from 250 megabytes a second to 500 megabytes a second. So this has benefited database backup workloads, that typically run single-threaded from one client, but also analytics jobs. And you're able to achieve the same level of throughput with fewer instances. So another way to look at that is that the per client throughput that we launched this year really helped customers reduce their compute spend by up to 50%, since the same unit of compute can now drive twice the level of performance. And finally, small file performance is another area that we've doubled this year. So that benefits workloads like web serving, but again, developer productivity tools. So if you perform an operation like get clone, super common in the development environments, what you'll find is that Git clone performs twice as quickly on EFS than it did at the beginning of the year. Wrapping things up here, 2020 has been a really busy year for us, as you can see. We didn't have time to go through every single launch in depth, but wanted to present a more complete picture here and maybe summarize some of the themes. So again, regional availability, EFS is now available in every AWS region. We've boosted our performance in a number of areas. We've added some really cool capabilities, really powerful around security and multi-tenancy with IAM and access points, and really evolve the art of the possible with file systems, cloud-native applications built on file systems in the cloud by integrating with AWS modern compute services in containers and Lambda. So we've been really excited to see how customers have already picked this up and adopted some of these new capabilities, and we remain equally as excited to see what customers build in the future. So thanks again for your attendance today. Just wanted to show some additional deep dive sessions on EFS in this year's reInvent. Encourage you to check them out, whether you're interested in some of those container and serverless integrations, more information on security best practices, on price and performance, and so on. And thanks again. I really hope you enjoyed today's session. Definitely reach out if you have any questions. And please be sure to fill out the survey here at the end and let us know what you think.